Now, next example is called pattern matching. Pattern matching is we wanna compare a specific value in the column with some patterns. And to make a kind of a pattern, we can use two notations. One is underbar, and the other one is percentage sign. So we use this underbar or underscore sign as a symbol for any single character. And the percentage sign is the symbol for any number of characters. So, for example here, I want to list all products with a name or product description that starts with B. Go back to server, and here in this SQL window, so in this SQL window, we will select P description from product. And then where we will check P descript, and we wanna compare each value with a kind of pattern. To compare the pattern matching, we can use the SQL syntax called like. And then here inside apostrophe, we can specify the pattern. In this case, it starts with B, uppercase B, and then after B, any number of characters can follow B. So we can add $sign and close it with an apostrophe, and let's close this select statement. So if you click Go, now you can see P descript. We have all this product starting with uppercase B, and after B, we don't care the number of following characters because we use percentage sign. Another example of a pattern matching, if we wanna list or jigsaw products, this jigsaw will be included as a part of product descriptions. So in that case, let's slightly modify the previous SQL statement. So instead of previous pattern here, how can we change this? First, yes, we have to include jigsaw. And then, what else we need? For this pattern, only if jigsaw is included as a part of product description, that's fine. So in front of jigsaw, there could be any number of characters in advance, and also after jigsaw there could be any number of characters following jigsaw. So if we click Go, you can see there are two products, and in the middle there is kind of a string jigsaw. So we can find this. And then, as the last example for this pattern matching, suppose we want to find products with 1 as the third letter of their code, product code. So we will use product code. And for example, in this result, you can see the third letter is 1. And after 1, any number of characters can follow. But in front of 1, there are only 2 characters. So how can we write down SQL statement in query window? We will select let's say P code and P descriptions from product table. So let me write down select P code, P description from product, and then the condition is where, and we use, in this case we are using P code, product code, and we are using pattern matching, so like, and inside this apostrophe we have to specify the pattern. So yes, we want to include 1, and then after 1 there are could be any number of characters, so percentage, but in front of 1 we need only 2 characters. So let me add 1 underscore and then another underscore. So actually this is 2 underscores. So by specifying this, we can say 1 is the third letter of the product code, and after that there are any number of letters can follow. So if we close it and let's click go. So currently we have only one product code. Again, this may be different result from the result given in your class notes. Because you may remember we deleted claw hammer using the previous practice examples. This is the result based on the current data set. So now, as the last example of pattern matching, we want to find products that are neither saws nor screws. So how can you combine two different pattern matching conditions? Again, in this SQL windows, we are looking at product code and the product description from product table. So let me write down this first, and then so there are two conditions. So let me write down two conditions separately. So the first condition is product description is like. No, it's not like. So P description instead of like, we have to use not like. And then what is the pattern? Because here it's saws, so, and what is the pattern? Inside apostrophe, any number before so and any number of letters after so. And then another pattern matching condition, instead of so, there is screw. So SC, screw, and in front of screw, any number of letter and any number of letter after screw. And then how can you combine these two pattern matching conditions? We should use and then let's close it. So click go. So you can see there are a list of products, and if you look at P description carefully, there is no saw and there is no screw. So neither saw nor screw. That is the condition we used for this example. Now, some other issues. First, ordering output. We can order either columns or rows, right? So if you wanna order or change the sequence of columns, what you can do is you can modify the sequence of these column names in your select statement. So here we compare two select statement, and in the first select statement, the P code is advanced by P description, but in this case it's swapped. So the result is based on the column sequence that you use in your select statement. And for ordering rows, we can sort rows using the SQL clause called order by. So using this order by statement, by default, we can sort the data in an ascending order. So A to B, B to C, like this. You can also sort the data in descending order, but in that case it's not default, so you may need to specify it after the column name. I will show you the example shortly. And also you can combine more than two columns for your ordering. So that means you can sort on one column, then again you can sort on another within each groups. So you may better understand if you read these examples. So suppose we want to list all products where price is at least 30. So there is one where condition. But after that, we want to order the report in descending vendor code. So the first column that we want to use is vendor code, and we will use descending order. So is it default? No. By default, it is ascending. So since it's descending, we may need to specify that this is a descending order. And then, where vendors are identical, list the products in alphabetical order of product codes. So in a group, we want to use the second column that is product code, and in that case, we will sort it in ascending order. So this is a default order, so we don't have to specify that it's ascending. So how can we implement this? So in the server, we will select everything from product, and based on the condition about the p price, let's add one where condition like this. So select everything from product where p price is greater than or equal to 30, and then we can add the ordering. So how can we do that? You can type in order by, and after then column name. So what's the first name? First the column name. We want to use vendor code for this sorting. And when we use vendor code, is it ascending order or descending order? Descending. Since it's not default value, so we have to specify that it's descending. And then, can we use another, second column for this sorting? Yes. In a group of same vendor code, we want to sort this data based on the product code. So add a comma, and we can add the second column, so product code. And when we use product code, is it ascending or descending? It's ascending. So if it's ascending, you don't have to specify that it's ascending. So if you click Go, you can see that now the data is sorted, and first it's based on the vendor code. So you can see it's sorted by in descending order using vendor code. And in a group of same vendor code, this data is again reordered by product code. In this case, yes, ascending order. Now, next one is about regarding to derived data. You may recall when we talk about normalizations, if there is any derived value you need for the actual report, do we need to store it? No, because we can always get the derived value using the raw fact, right? So for example here, we want to get product code, product description, price, on-hand quantity, and the last one is called the inventory value. So by definition, what this inventory value means is price multiplied by on-hand quantity. Since we have price and on-hand quantity as the raw facts in the table, we can calculate inventory value for each product. So in the server, what we will list up is select some existing column is product code, product description, product price, and product quantity on hand. And then they ask to show the derived value that is called inventory value, and the formula is given. So using the existing columns, we wanna multiply p price star and p quantity on hand. And here from product. So let's try to run this statement first. If you click Go, you can see p code, p description, p price, p quantity on hand, and p price multiplied by p quantity on hand. So this is the meaning of inventory values. But the actual column does not exist in the table, right? Sometimes it may be helpful to use some meaningful name even for these derived columns. So in that case, instead of p price multiplied by p quantity on hand, let's name it as inventory value as a kind of alias. To modify the existing SQL statement, on this screen, you may click Edit button. So if you click Edit, you can see the pop-up window. And in this pop-up window, we have original SQL statement. And here, after this derived value column, let's use alias called the inventory. value as a name. Then, since we use this as an alias between this actual formula and this alias, we have to put a syntax called as. So here you can see you will use this formula, but we will name it as inventory values. So if you click go, now yes. So here we use inventory value as an alias for the derived column.